let's find the domain of radical functions. And so what we're looking at here is what are the legal inputs that will give us real number outputs. And so there's a distinction between odd and even radicals. And specifically it's this. Remember, for our evens, when n is greater than or equal to 2 and even, then the radicand has to be greater than or equal to 0. If n is greater than or equal to 3 and odd, then the radicand has to be, or can be rather, be anything. Now, there's one catch to this, because it still has to be a real number. So, if I were to look at the cube root of 1 over x, then x is everything, because it's a cube root, except 0. Because x can't equal 0 here. It's in a denominator. So, with that in mind, as long as there's nothing else funny going on, in a 10-10 we don't let anything else go on in our intermediate algebra class. We can look at a function, f of x equals the square root of x minus 2, and we stop and we say, oh, this is even because it's a square root. So we take the radicand, x minus 2, and set it greater than or equal to 0, and then solve. This is x is greater than or equal to 2, or in interval notation, notice the square bracket for the 2, and it goes to infinity because it's everything from 2 and up. And we have answered the question. Or we could say g of x equals the cube root of 7x minus 1, and we say, oh, this is a cube root, so it's odd. We look inside at the radicand and say, it's just a polynomial, so then my answer is from minus infinity to infinity, and I'm done. If h of z equals fourth root of 3 minus 2x, of not x, we've got to make sure this matches, of z, we again notice that because it's a fourth root, it's even. So we take 3 minus 2z, set that greater than or equal to 0, subtract 3 to get minus 2z is greater than or equal to minus 3, divide by a minus 2, and when I do that, because it's an inequality, it becomes a less than or equal to 3/2, so z is less than or equal to 3/2, or in interval notation, minus infinity to 3/2 with a square bracket. Now I just want to, just in closing, re-emphasize that if we have f of t equals the cube root of 1 over t minus 2, then because it's an odd root, it should be from minus infinity to infinity, but it's not because of this little tricky piece right here which says t cannot be 2. So it's everything but 2. So in set builder notation, it's all values of t such that t does not equal 2. Or now that we can talk about this, it's everything but 2 in interval notation. Everything less than 2 and everything bigger than 2, but not 2 itself.